All right, so here's our second video on limits. Now, when we're talking about limits, we need to specify the difference between what a limit is and what a value is. So we have value. All right, we have the word value, and then we have the limit. So when we're talking about graphs, lines, quadratic equations, or just anything dealing with curves and lines, you're talking about functions, right? And those functions are dependent upon the values that hold true to that function, right? Now, when we're talking about calculus, we're talking about studying different type of functions as they behave around different points, and that is called a limit. When you're trying to describe how a function behaves near a point instead of at a point, which would be the value. Okay, so when in calculus, when we're talking about limits, we write with the notation of the function as x approaches 1. What is the function of x plus 2? So how is this function behaving when x approaches 1? Now, also, we have to take consideration of a two-sided function, and a two-sided limit and a one-sided limit, or just a limit that has one side. So what I'm saying is, if I approach 1 on the left side of the function, I should see I get really, really close to 3. And also vice versa. As I approach 3 on the right side, I'm also getting really, really, really close to 3. So I can assume that the function of x plus 2 as I approach 1 is going to be 3. And that's just looking at the graph. Now, algebraically, if I just put 1 for x, 1 plus 3, 2, then the answer is also 3. So I can conclude that the limit as the function of x, which is x plus 2, as it approaches 1, is 3. Now, this is not the value. Okay, this is not the value. Now, some may want to plug 1 inside of there, and you see you will get 3, but that's not always the case. Let's look further. Now, if we look at this graph here, we see that we have an empty circle. Now, the function as it approaches 1 of x plus 2 is 3, but the value is undefined. All right, so this will be actually undefined. Now, so that's the difference between limits and values. And we care about limits because we want to study lines as they approach different points, because functions or lines behave differently when they're around different points, but they just may not be equal or have a defined value at that point. And that's very, very important. So let's go ahead and do some examples. All right, and then we're just going to do some math. All right, so example. Let's say I have the limit as x approaches 2. How does this function behave as it approaches 2? All right, so if you haven't taken calculus or dealt with limits, your intuition might just tell you just plug in 2, and you'll do 2 squared minus 4, 2 minus 2, which you'll get 4 minus 4 over 0, which is just 0 over 0, which is undefined. This, so that may be true, but it may not be true. So you have to, so if you get undefined when you plug it in, you're not done. You have to figure out if the function actually behaves some type of way around as it approaches 2, or do we get some type of value when we approach 2 for this function? So remember, we're caring about what's happening around the points, not what is the value of the points. So let's go ahead and redo this problem. But this time, we're going to factor out this quadratic equation I have, and then see if I can plug in and then find a value, and see if my function behaves differently. So I have a perfect square here, so I can just go ahead and break that up to x minus 2 times x plus 2 over x minus 2. And we see that these two are going to cross out. So then I'm left with x plus 2. So the limit as x approaches 2 of x plus 2 is 4. So we see that when you break up the function and you break out the factors and you plug in what is approaching, you see that it has a value of 4 when it approaches 2. Let's do another example. So let's say I have the limit as x approaches 5 of x squared plus 2 plus 2x minus 4. Okay, so we can break this up or we can just plug it in. Okay, I think I'm gonna just go ahead and plug it in. So I have 5 squared plus 2 times 5 minus 4, which is 25 plus 10 minus 4, 35 minus 4, which is 31. So as the limit as x approaches 5 of x squared plus 2x minus 4 is 31. Example 3. We have the limit as x approaches 3, x cubed minus 27 over x minus 3. All right, so this is another one. If we just plug in the 3 cubed minus 27 over 3 minus 3, you're going to get 0 over 0, which is undefined. So then we have to factor it out and see if the function actually behaves differently before we conclude that. And also, when you're dealing with limits, you're not finding the value again. That's only if you were trying to find the value. We're trying to see how it behaves, so we don't care about it being undefined. So we're going to go ahead and break this perfect cube up. So that is just the equation. Put this in red or burgundy. It's a minus b times a squared plus a times b plus b squared. So if we break this up, when we factor, all right, so a and b is just to simplify. So a, b, that's going to be x and 3, x minus 3. All right, so if x is a, x times x is x squared, because that's a squared, minus, because 3 times 3x, excuse me, you keep that plus sign, plus 3x, because 3 times x is 3x, so don't include that sign. And then we have 3 times 3, or b squared, which is 9, over x minus 3. All right, we see that these cross out. Whenever you see that, you know that you're doing something right. All right, and now we can go ahead and plug in our 3 here. So we're going to get 3 squared plus 3 times 3 plus 9, which is 20, 9 plus 9 plus 9, which is 27. All right, so the limit as x approaches 3 of x cubed minus 27 over x minus 3 is 27.